In this video, we will be discussing angle-side-angle congruence, also known as ASA congruence. And it states that triangles can be proven congruent when two angles and the included side, or the side between the two angles of one triangle, are congruent to two angles and the included side, or the side in between the two angles of a second triangle. So it looks a little something like this. If I have angle A, an angle E, and an angle B, an angle F, and their included side would be the side in between them, then these two triangles are congruent by angle, side, angle. Notice that I go angle, side, angle. Okay? And we have a couple of proofs that we can do to prove this. So, looking at our first one, we are given that angle BDC, so BDC, so this angle right here, is congruent to ABD, which is ABD, so this angle right here. Okay, so we've labeled our picture. And that AD, so this guy, is parallel to BC. Okay, so we got all of our stuff labeled on our picture already. Now, some things we know is that BD here, segment BD, is probably reflexive, so we can make a note of that. So segment BD is probably reflexive because, as you see, BAD, so triangle BAD and triangle DCB both share this line here, so we know that this guy is probably reflexive. Okay? So, if we do everything that we have here, we can write our givens. So we had angle BCD is congruent to angle ABD. We also have segment AD is parallel to segment BC. So there's our givens. Now it says something along the lines of alternate interior angles of parallel lines. So if you recall, I have two parallel lines here. And then I have alternate interior. Well, my alternate interior angle, if I were to continue this, would be this angle here. And if I continue it, it's going through the parallel line. So it's not going to be that guy, but it's this guy right here. And so we see we have alternate interior angles now. Okay? Which gives us two angles, which helps us eliminate like side, side, side. There's no right angles, so that gets rid of HL. And there's no, and we have angles, so it gets rid of side, side, side. And we have two angles, so that gets rid of side, angle, side. And so if we take a look now, we could say, okay, angle ADB, which is this guy, is congruent to angle CBD because of alternate interior angles. So this angle and this angle are my alternate interior angles. Okay? Now, we have two angles, and in order to have angle, side, angle, we need the segment between. So I have angle B here and angle D, and notice that both my angles are occurring there, so I need the segment that's between them so that I can use ASA. And well, we see that BD, segment BD, is congruent to segment BD. And how do we know that? Because it's the same line, and therefore it is reflexive. So triangle BAD is congruent to triangle DCB by angle, side, angle. Okay? So we're going to do one more example, example 2 here. And notice in this example here, we don't have any boxes, so it's up to you on what we do. We're given that angle E and angle H are congruent, so we can label that. So we have angle E and angle H are congruent. Okay? We know that J is the midpoint of EH, so we know that this segment and this segment are congruent because that is how midpoints work. And that's all we're given. Now, one other thing we should note is remember when two lines cross, the angles across the intersection are congruent. because of vertical angles. So before we do our proof, notice now we have angle, side, angle. So that's probably going to be our reason for why the two triangles are congruent. And we also have already mentioned that this is vertical and that these are congruent because definition of midpoint. Okay? So notice how I'm annotating and I'm working the problem in the picture before I even attempt to do the proof. I'm looking for all of the things that I can do. I'm labeling my givens so that I can answer the proof really easily. So let's get started with the proof. The first thing we should write is our givens. So we have angle E is congruent to angle H, and J is a midpoint of segment EH. And that reason is a given. So we had two givens. Angle E is congruent to angle H, and J is a midpoint of segment EH. Now, why are we using one letter for the angle instead of three like we did up here? Well, because there's only one angle at each of these letters. Unlike J, which has two angles, we would have to use three to denote what the angles are, which we'll do in just a second. Now, we can say that segment EJ is congruent to segment HJ, and the reason for that is what we said, definition of a midpoint. Since J is a midpoint, this segment here and this segment here are congruent, and J is a midpoint of EJ and HJ. We can't say anything about F and G because they didn't give us any information about that. But we could say that those two pieces are congruent by definition of midpoint. Then we can go to the next part where we said, hey, there's vertical angles at point J. So we can say that angle EJG or GJE is congruent to angle HJF or FJH because they are vertical angles. Okay? So because these are vertical angles, we know that vertical angles are congruent, and so we could say the two angles are congruent. And now I have angle, the included side, which is between the two angles. So I have angle, side, angle. So I can say by angle, side, angle, triangle EJG is congruent to triangle HJF. So the two triangles are congruent because of angle, side, angle. And that's how we do this proof.